Hello, this is Andrew. Today I'm going to talk about some of the basic operation of a DCOE carburetor, which most of them are Weber's. This one's a Mikuni here. Just the operation and some basic tuning that can be done on the car. I guess we'll first start off with the way these carburetors operate is that as you open the butterfly here, and you see the butterfly is opening right there, air is pulled through into the engine, and gasoline is pulled into those chambers to provide to the engine. It's done through a couple of what they call fuel circuits, an idle circuit and then a main circuit, and then it also has an accelerator pump, but we won't get into all that today. We'll just get into kind of what the basic features and operation is and what you can do to if you're having trouble with your engine running correctly on it. So we'll start right now first, right here, and I've disassembled this one a little bit just so for the expediency of time. This is your jet cover, and this is where your jetting that tells you how much fuel goes into these carburetors is. You'll have an idle jet and you'll have a main jet, and we're going to pull those out and have a look at those right now. If I can get it out with my shaky hands. Alright, so this is your typical Mikuni idle jet. And like I said, the Webers are going to be a little bit different. I'll do something, another video on the Webers. But the Mikunis have an idle jet that fits into there. They come in different sizes. You can see the size on the top right there. You can't really see it in the video, but it does say 60 on it. So it's 0.6 millimeters. That has a designated size for the hole for air and for the hole for the gas. The 60 is really for that gas hole right there. And making these larger and smaller can affect the 0 to quarter throttle range in your idle. In addition, the way you also tune the idle circuit is these screws right here. These are really for just idle. So once you get kind of a baseline jetting done, you run these screws all the way down, assuming everything's been cleaned and in good working order, down very softly until they just touch. And typically what you want to do is you want to run them back about 3/4 of a turn from Mikunis to 1 turn. That's your starting point. Okay, and that'll get you in the ballpark so the engine will crank and run. What that does is it allows fuel to actually get down into the chamber without the butterflies opening. It's in front of those butterflies. So the engine's sucking that fuel in when you crank it and you start it before you hit any throttle. But that same circuit that you see right here, this idle circuit, also provides fuel for that 0 throttle all the way up to about 1/4 throttle. And it's important to get those right, because if you don't get those right, as you make the transition between 1/4 throttle and going into half and full, you'll have a dead spot there. And so it's very, very critical as a first step to getting these correct. Now, kind of moving on, because we're just kind of doing an overview on this one. Moving on to your main jets. Which are accessible by the top. And it's done deliberately to where you can access them very quickly at the track and make any changes that you need to make just by taking this cover off. You don't have to take off anything else to get to the jets. So your main jet that sits in here like this has your main jet here, and it has what they call an emulsion tube, which this emulsion tube is really what sets your fuel curve. It tells it how much fuel to put in to the motor under different loads and different engine speeds. And there's kind of an art to selecting these in most cases, especially with the Webers. The Mikunis is a little more standard, but these holes you see in the side allow air to come in as well as fuel here and emulsify together, as again the term emulsion tube. And that combined air-fuel charge goes through a series of passages in the carburetor, and as you open the throttle, it will pull more of that air and fuel in. And the jets, the main jet is here. Again, they have numbers on them to give you sizes. And then there's an air jet as well. So you're letting fuel come in this way, up from the bottom, or around from here, and then you have air coming in from the top. And having the right type of emulsion tube and having the correctly sized air jet, which you can kind of see right there inside. I'm not going to take it out at this time, but those also have a number on them. And the emulsion tubes usually have a stamping, like this one has AO on it for the Mikunis. The Webers have a series of like F11, F9. They don't really make a lot of sense. I think it's a really old way of categorizing them, but there's usually a chart. They'll tell you what emulsion tube will give you certain characteristics with what engine, but we can get into that later. So the jets sit in the float bowl chamber, and this cover right here, this is the choke mechanism that you can see, that when you pull the choke lever, it opens it up like that. So we'll take this off so you can actually, oh, and the other thing that you've got on the Mikunis, which is really nice, is you have an external adjustment for your float height. And that's probably one of the most critical things that you can have on these carburetors to have correctly before you start on any other method of tuning with it. So we're gonna lift this off now, very, very carefully. And like I said, I already pulled it apart some. Okay, so there's your float chamber, and here are your floats here. And the floats sit in there like this and move up and down based upon the level of fuel in this area right here. And the reason this is so critical to have correct, and what you'll measure when you set your floats up, you'll have it, most DCOE carburetors have you set it like this to where it just barely puts load on that little needle valve. There's a little needle valve in there, I don't know if you can see it right in there, that allows fuel to come in, and as the floats rise, they turn the fuel off. But it's very critical to get that right. And what you do is once you get this in here and you make that adjustment, you can actually do a bench setup where you measure how many millimeters there are between the surface here and the float height here, and that'll give you the ability to get it pretty close. Then when you put it all back together, make sure I do this correctly and not damage it. There we go. When you get it all back together and you've got that bench setup of the floats correct, and you got your jets kind of where you want them as far as a baseline, and there's books and formulas. You can go online and it'll give you kind of a baseline of what your engine size is, what your RPM range is, how heavily modified or how high performance it is. It'll give you kind of a baseline for that. That'll tell you what size jets to begin with. But once you get it up and running, you can find a tool where you can actually pull these out while the car is just idling, or just after the car stopped idling, I should say. And it's got a little device that you go in, this little tube that you put your finger over and pull it out, and you can get a finer tune adjustment on what your float level is. But kind of going back to that float level controls everything else, because the level of the fuel in that chamber determines how well this emulsion tube and your fuel curve operates, and it affects everything. That's the first thing that you want to get right more than anything else. Again, kind of to recap, you got your idle jets here that control your idle as well as at 0 to quarter throttle, and then you've got your main jets here that in your emulsion tube, and your air jet on top that really kind of controls everything else. That's kind of a basic overview of how these function. And you can also control your float height with this lock screw right here. You take that lock screw off and adjust it, and it'll move it up and down. Anyways, thank you for your time.